Hello, well, I'm making this video as the design as for the design for the foundation, mat foundation of this tall building, which was earlier designed and as part of the online course conducted by Skyfi Labs. So, for the design the mat foundation, we have 16 columns at the base, and we need the load values and sizes of each column. This can be obtained from the e-tabs. We had already done the design, so after doing the design, go to tables and go to analysis results and table element forces columns. Open the table, and there we have different stories, but we only need the bottom story, just story 1. The load at the bottom stories is the only one which we need, and the output case, we have both dead and live for the design, so we need to check those separately. And then the station denotes the point on the column where you get the load values. We need it at the base, so it's 0. Now we click OK. uh, Now you will see that all these columns C1, C2, C3 for different columns, the dead load and the station is 0, and we have the column point load acting on the column. Now you should note all these values, and the same way go to filter and make this live and get the next values. So you have got all the values. Now you see you have 16 columns, C1 to C16. Now the next thing which we need is the size of those columns. For that you go to model, structure layout and structural objects, and there you go to story 1. Story 1, you open that, and there you will have columns. So you have C1, C2, all these columns, and there if you open C1, go to the assignments, and there you can see C500. That means it's a 500 into 500 column. At the same time, all these columns at the edges are of 500 by 500, but this middle columns, which is these 4, that is C7. C7 is of 600. So these 4 columns are of 600 by 600 size. To know the name, you can actually go to the 3D view and click the column. So here you have the 3D view, and if you click this column and you right click on it, you will see it's C4. That means the left top column, this one. And if you go here and click this column, if you go and click at this column, it will be C1, and then this one is C5. So the order is C1, C2, C3, C4, C5, C6, like that. 16th column is over here. So after getting all these details, we can proceed to the design in safe. So as usually when we want to create this, we go and select new model. We enter all these parameters, and we will enter as usual IS 456 under the minimum cover as 50. As a minimum cover as 50 mm both in top and bottom, and then you proceed as usual. And then we need to draw this slab or the mat foundation manually. For that, you're going to select the grid lines option, and there you have to draw the grid connecting the columns. So this size of this footing is 18 into 18. So you make a grid with 19 lines on both X and Y and 1 meter interval grid spacing. Now after making that, you create the slab. Then there you will define all the materials, HYSD M40. You have the slab properties, which is the footing. There we had made it type mat, and this is the final thickness which we got, but initially we'll start with a smaller thickness of say 500. Slab material is M40. Then we continue on to the column properties, and we have two types of column: 500 by 500 and 600 by 600. See here, you can see column 1 is of 500 by 500 size and 40 material, and the other one is also of 40 material. Then another thing for us to define is the soil subgrade properties, and this K value, subgrade modulus, which we got from the bearing capacity by allowable settlement ratio, and that was also entered 3 into 10 raised to the power of 4 kilonewton per meter cube. Then we had designed all the load patterns, which was dead and live, load cases, dead and live, lead combinations. We have two combinations, one for strength and other one was serviceability. Here for combo 1, which is for the strength, it is 1.5 scale factor, and other one it is 1. So after defining all this, then we draw the columns. We use the grid lines and we place the columns over here. And as I mentioned earlier, we had drawn the slab for 18 by 18, but to cover the area of the columns, we had to extend this bit. So we had selected the slab, and in the edit option we have an option to edit the areas. If you see now, with since the model is the model is unlocked, if you select this, you go to edit and edit areas. You have expand or shrink, so we can set the offset value. Here we had increased both the length and towards one side by 2 meter each, so 2000 was entered here, and this got extended in 2 meters over here and 2 meters over here. So then we also assign the soil properties as soil, and then we will draw the strip lines. So the strip line width was calculated as 0.25 times the shortest dimension. The shortest dimension came to be 18 meter. So 0.4 into 18 was 4.5, but for more accuracy we are taking a small value of 4 meter. So with that 4 meter grid line, we had drawn strip lines of 4 meter width in the X direction layer A and the Y direction layer B. So after completing that, then the next step was to assign the load. So we had to individually select each column and then enter the live load, dead load separately, and also the dimensions of the loads. So after doing all these things, then the next step was to run the analysis. So we will run the analysis right now. And see, here we got the displacement values of the slab, and can also we can run the analysis and design. So after running the design, if you go to display and show the failure criteria, just punching shear diagram, you'll see that all the punching shear ratios are below 1. So it means that it has passed the test, or the thickness of the slab is sufficient. Then we can see the slab forces acting on it, the strip forces. We can generate the BMD or SFD. If you go here, we choose moment, and for dead load, layer A, layer B, both the layers apply, you can see the BMD. Similarly, in the display section, we have other options such as to show the slab design, which will give the reinforcement details. So always impose the minimum reinforcement, and for layer A, just see on through the x-axis. So here we can see the values. Then you can see as we went for detailing. So we ran the detailing. So here we got the final detailing diagram, and before that, you can also see the drawing components as a slab view, the rebar bill of quantities, the length of bars, the schedule, what all different types of bars are required, and the individual slab views. You can see the plan, rebar plan. This is the top rebar plan. This represents all the bars together. So similar bars, you can see the sections, cross section view, This is also the reinforcement profile. You get all these details after